In the last class, we have discussed regarding what is landfill. We have discussed what are the different methods of landfill, that is area method, trench method, canyon method. Then we have discussed regarding the advantages and the disadvantages of landfill. Then we have discussed on the site selection for landfill, and also we have seen what is this particular liner material, how we are going to add the solid waste in the form of heap, and then again we are going to close it, and how we are going to collect the landfill gas that is going to generate, that we have seen. And we have also seen what is leachate and what facility we are going to have in the leachate collection. Now again we will see what is this particular leachate. Leachate is nothing but when we are going to keep the biodegradable waste material, right, and we allow it to degrade. Whenever after some amount of time, right, that particular degraded material, it start to give the liquid out of it, right, it is going to give you the liquid. That particular liquid, due to decomposition, whatever we are going to generate, that we call it as an leachate. Now how the gases are going to generate, we are going to have the solid waste generation, right, we are going to keep it in terms of heap of a solid waste. Then once the trench is going to fill, we are going to close it with the help of liner. Now when the biodegradable material, it is going to decompose, it is going to generate the gases like methane. Okay, how the gases are going to generate, we are going to keep the waste material, right, by compacting, and then we are going to make the cells. Then at the end, at the bottom and at the top, we are going to cover the liner to it. Now when we have covered it with the liner, that means what we are going to generate, we are going to generate the gases out of it. So what kind of a gases we are going to generate, we are going to have the methane and CO2. This methane and CO2 will be utilized, right, as a source of energy. So in today's class, we are going to discuss regarding this particular leachate and this particular the landfill gases. Leachate, one more thing what I want to tell, I'll just give an example of a we will take an example of a apple, right. We suppose if we keep it on a table and without using it, if we simply keep it for the period of 15 days, right, what it happens, as it is a biodegradable material, now what is going to liberate, the one kind of a liquid that is going to this particular rotted or this particular biodegraded apple is going to liberate one particular liquid. That particular liquid we call it as an leachate. This particular leachate is harmful, it should not enter into the ground. Okay, if it is going to mix it with the soil, then it is going to create a problem. It is going to disturb the pH of soil. Again the consolidation of the soil is going to take place, right, and then again it is going to affect the minerals which are there in this particular soil. So we needed to take care regarding this particular leachate and the gas. Now in today's class, we are going to see how the gases and leachate are going to be generated, what are the different phases of that, and how we need to take care regarding the control of those gases and leachate generation, how we need to have a control on it. Now due to the decomposition under the anaerobic condition in the landfill, we are going to, especially we use anaerobic condition. Anaerobic in the presence, anaerobic means it is in the absence of oxygen. Now as we are going to have the liner over the material, once the landfill area is going to be get filled, we are going to cover it by the liner. When we are going to cover it by the liner, initially aerobic condition was there, then it is going to become anaerobic once we close it, and suddenly it does not become anaerobic as the microbes are working on that particular degraded waste material. Then aerobic condition will turn into the anaerobic condition. So we are going to get the different types of gases in the landfill. So we are going to have the principal gases like, that is carbon dioxide, that is CO2, and methane, that is CH4. This is the main gas that we are going to get it from the landfill. Okay, then the trace gases will be having, that is NH3, then H2S means hydrogen sulfide, then N2 is nitrogen, O2 is oxygen, then carbon monoxide, and H2, that is the hydrogen. This particular H2S is going to give the NH3, that is ammonia, and your then H2S. H2S is going to give the bad odor to the landfill area. Okay, so we are going to have the principal gas CO2 and methane. These are, it can be utilized as a source of energy, and the trace gases will be having all these compounds. In this, the hydrogen sulfide is going to give the bad smell, right? Then the CH4 is present in the concentration between the 5 to 50%, and it is explosive. So whenever we are going to deal with this particular landfill, we need to take care regarding this particular methane gas. Nobody should have, say, if by any chance there is an spark of fire is there, then it may, and there is some leakage in the landfill area, then it may catch a fire. So it is, methane is a very explosive kind of a gas. So we need to be very careful when we will be treating, or when we are going to deal with this particular methane. Okay, then under the normal condition, gas produced are released to the atmosphere by a diffusion. That means the whatever the gases are produced in that particular landfill, it is going to be released to the atmosphere by the diffusion. Okay, both CO2 and methane are found in the concentration up to about 40%, and it is the greenhouse gases. GHG means it is a greenhouse gas. Okay, so we need to take care regarding this. There should not be any kind of a leakage into the landfill area. Then we will see the CO2 is 1.5 times denser than air. Okay, that means it try to settle at bottom, and then it is 2.58 times it is denser than methane. Hence it is going to have the downward motion. This CO2 will be having the downward motion. Both these, methane and the CO2, will be having the downward motion, but CO2 is more denser than the methane, so it will try to be there at the downward surface. So this is regarding the composition and the characteristics of the landfill gas. Right, now we know how we are going to get the gases. It is due to the anaerobic decomposition. We are going to close the landfill site with the help of a liner. So slowly it will become aerobic to anaerobic, and the gases will be generated. And the your leachate, how it is going to be generated? Due to the decomposition of the biodegradable waste material. So we needed to take care regarding whatever the waste material we are going to add into this particular landfill area. It should be complete. It should have only the biodegradable waste material. So whenever we are going to have the segregation of the materials, we should do very carefully that it should not have any kind of a metallic, or it should not have any kind of a non-biodegradable materials like plastic and all. If metals are there, then it is going to cause corrosion, then it may lead to some other problem, right? So, and again, the plastics and other non-biodegradable waste material, it should not enter into the landfill area. Okay, now we will see some of the waste material that can be added into the landfill. The waste material, like the biodegradable material like your food waste, newspaper, cardboard, yard waste, and other biodegradable material that we can add into the landfill, these are the readily biodegradable. That means it is going to be fast degradation will be there about these material. Then any kind of a textile, that is clothes, then rubber, leather, wood, and other mix kind of a element, it is going to be slightly biodegradable. And the plastics, metals are strictly non-biodegradable material that we should not add into the landfill area. the gases whatever we are going to get into the landfill, initially it is going to be a bit slow, right? And it will take around 2 years to generate the gases, and after 2 years it reaches within 2 or near to the 2 years it reaches a peak, and then the slowly it is the generation of gas is slowly it is going to get degrade. Generation of principal landfill gases and leachate in the different phases. This generation of this particular gas and this particular leachate, it will be take in different phases. That is phase 1 we call it as an initial adjustment phase, that is phase 2 we call it as a transition phase, then phase 3 we are going to call it as an acid phase, that is it is going to be divided into two phases. The acid phase will be divided into two phases, that is first step we call it as an acidogens, and the second step we are going to call it as an acidogenesis. Then in the fourth phase we are going to have the methane fermentation. Here we are going to have the acetic acid generation to see methane. Then phase 5 we are going to have the maturation phase. So all the both the leachate and your gases will be generated in these particular 5 phases. Now we will see one by one. That is the phase 1 we call it as an initial adjustment phase, that is in the aerobic condition. Now this initial adjustment phase means what? Now when we in the phase 1 when we are going to dump the waste material into the landfill area, right, what happens is we are it is still under the aerobic condition. Why is we have just closed the liner material above the landfill area. Just a minute, I'll show you how we are going to have it. Okay, here when we are going to place the waste material into the landfill area, right, and if we suppose if we have closed it, now there is an oxygen amount will be there in this particular landfill. Right now once we have closed it, that means it doesn't mean that all oxygen whatever it is there it is going to diminish. Okay, it still there will be some amount of oxygen. Now in the initial adjustment phase what will happen is these microbes whatever it is there in along with the biodegradable waste material, it will try to decompose the waste material for their survival under the aerobic condition. Now slowly what will happen is this aerobic condition whatever the suppose initially there is around 80 or 60 or 70% whatever the oxygen content is there, as the time passes, right, the oxygen content it goes on reducing. So in the first phase will be the initial adjustment phase. In this particular initial adjustment phase what will happen is the microbes will try to adjust with the particular atmospheric condition whatever it is there in this particular landfill area. Okay, then we are going to have the next phase that is called as a transition phase. Transition phase means the change in phase, that is from the initial adjustment phase to the second phase, that is the transition phase. The oxygen, as I have told, the oxygen it gets depleted, and from your phase 2 the anaerobic condition will start to develop. That means in the first phase the microbes were initially they were adjusting with the condition, and then as it is going to consume the oxygen whatever it is present in that particular the landfill area. Now in this particular phase the microbes have consumed the oxygen. Now in the second phase whatever the oxygen that was remaining it will be completely consumed by the microbes which are present in that particular landfill area. Then it is going to give you the anaerobic. Anaerobic means the decomposition will be taking place in the place of in the absence of oxygen. This is we call it as the transition phase. Now the phase 3 we call it as an acid phase. Okay, first phase will be initial adjustment, second phase will be the transition, third phase will be the acid phase. Now in this particular acid phase will be taking into two steps. Okay, first is we call it as an acidogens, and the second step we call it as an acidogenesis. Now in the first step what is going to happen is the higher molecular mass to the suitable, the higher molecular mass whatever is there, it is due to the decomposition of the microbe, it converts them into the suitable for the microbes. So it is going to, the acidogens will be getting converted. Then in the second phase, what will happen? These acidogens will be converted into the lower molecular acid like acetic acid will be going to produce. First, higher molecular compounds will be converted into the molecules suitable for the microbes. We call it as an acidogens. Then these acidogens will be converted into the acetic acid. So here what will happen is the CO2 is a principal gas along with the H2. The CO2 gas is also going to get generated. Next is the pH of leachate drops below 5. In this particular acid phase, what happens is the pH is going to drop below 5. pH of the leachate, that what we are going to get. Regarding leachate we were speaking that the liquid, right? The liquid pH is going to get reduced below 5. And the increase in the BOD and COD of a leachate. This leachate will be having the characteristics, it is an your chemical characteristics. This BOD and the COD are nothing but the chemical characteristics. These both are going to increase in your leachate. Okay. Next is the fourth phase is the methane fermentation. Okay. Here in the acid phase we have formed the acetic acid. Now this acetic acid will convert into the CH4 and CO2, right? In this here we are going to have the rise in pH of that particular leachate will be about 6.5. The pH leachate will again increase to 6.5. This here we are now we have reached the methane fermentation. Just I have told you that the gas generation will be in peak of within the 2 years. So now here in the methane fermentation we have reached that particular phase. Next is the phase 5 is maturation phase. Now CH4, methane and CO2 whatever is generated, that it is going to diminish slowly. That means the rate of generation of methane and CO2 will reduce. Okay, and it is going to have the fulvic acid and humic acid will be generated in the leachate by the anaerobic decomposition. Okay, so here these are the 5 phases. Initial adjustment phase, where the adjustment of the microbes will be done according to the climate conditions inside the landfill. Then transition phase, the aerobic to anaerobic condition. Then third phase we are going to have the higher molecular switch to the suitable for the microbes. Then acidogenesis. Then we are going to have the methane fermentation, that is acetic acid to CH4 we are going to have. This will be reached within 2 years. Then we are going to have the phase 5, that is a maturation phase. After this particular phase we are going to have the less amount of methane and CO2 generation. Now we will see how we need to extract the gas from the landfill site. Okay, now for this particular extraction of the landfill, the gas from the whatever the gases is going to generate, we are going to extract it with the help of the pipe. So we call it as a gas extraction pipe. This gas extraction pipe will be having around 4 to 6 inch, okay, and 4 to 6 inch in dia, and then we are going to have the 18 to 16 inch borehole for this. Then we are going to have this 2 to 3rd of a length of this particular extraction, gas extraction, we are going to have the PVC or PE pipe. Okay, then the remaining will be 1/3 will be towards the perforation. It is going to have the perforations. Okay, the landfill gas recovery wells are typically designated to penetrate 80% of the waste depth in the landfill site. That means the whatever the gases we are going to have, these will be the gas extraction pipes. It will be 80%, it is going to be penetrated inside this particular landfill gas, and it is going to have the downward motion, and we are going to have this for the 80% of the extraction. Now we'll see how to control the leachate that is going to be get generated from the landfill gas, okay, landfill area. Okay. Now, what is leachate? Leachate is nothing but the liquid that is going to be get generated due to the due to the degradation of these particular waste materials. Now, liquid will be always, it will be having the downward motion. Okay. Now, how we need to prevent this particular leachate? The first thing is we need to provide the liners at the top, and we need to provide the liners at the bottom. Okay, so we call them as the synthetic flexible membrane. Okay, these membrane should have a minimum thickness about the 40 mils. Okay, and liners must be installed to cover all the natural geological material likely to be in contact with it. That means we need to cover all these liner material, should cover wherever this particular solid waste is going to have the contact with the soil. We need to cover it. Then next is we are going to have the artificial earthen liners. Okay, that means we will be using the clay liners as an optional for the municipal solid waste landfills, and if required by the site conditions, clay liners for municipal solid waste with the minimum 1 feet thickness clay liner we will be providing, with having the maximum permeability of 1 into 10 to the power 6 minus 6 centimeter per second. That much permeability should be there in those particular clay liners. So if we provide these particular clay liners, whatever the leachate that is going to be get generated, it won't be in contact, it won't be in a direct contact with this particular soil. So this can be prevented by having the artificial clay liners. So in today's class we have covered the composition and characteristics of landfill gas, the generation of the landfill gases and leachate in the different phases, and how to control these generation of the leachate and the landfill gas. For the gases we will be having the gas extraction wells, and for the leachate control we will be utilizing the liners. In the next class we will be seeing the problems on the landfill area, landfill